Pythagoras theorem. Pythagoras theorem is used in right-angled triangles. Now the triangle must have a right angle, as we can see that this one does, which is marked by a square. In Pythagoras' theorem, you need to know how to label the sides of your triangle before you can do anything else. Now, the most important one to label is your hypotenuse. Now that is HYPOTENUSE, hypotenuse. The hypotenuse is always the side opposite the right angle, and it is always the longest side of the triangle. So I would always recommend that you start a Pythagoras' theorem question by doing an arrow out of your right angle so that you can find your hypotenuse, and then remember that that will be the longest side as well. It's generally easy to spot because it's slanty, whereas the other two are at right angles to each other. But remember, your triangle might be turned upside down or something that would make that harder to see. So arrow out of the right angle will always give you your hypotenuse. Now in Wellington, we refer to the other sides as side 1 and side 2. Now, if you have learnt Pythagoras' theorem somewhere else, you might be more familiar with A, B and C for labelling your triangle, where C is your hypotenuse. And that's absolutely fine as well. It's just a different way of referring to the sides. But as what I'm going to be using will be the side 1, side 2 and the hypotenuse. Now, what we need to know is what is our actual formula. And the formula is this: side 1 squared plus side 2 squared equals the hypotenuse squared. Or alternatively, you may know this as a squared plus b squared equals c squared. But again, I'm going to be sticking with the side 1 squared plus side 2 squared equals hypotenuse squared. What that means is the sum of the squares of the smaller two sides equals the square of the longest side. And it's very, very easy to use. Let's try some examples. Okay, the first type of example that we're going to look at is finding the hypotenuse. Now, what I would recommend that you do, as I said, is draw an arrow out of your right angle to identify your hypotenuse. The hypotenuse is the side that matters. Once you've identified it, it doesn't actually matter which one you put as side 1 and which one you put as side 2. I tend to put side 1 at the bottom and side 2 at the side, just to be consistent. We then write out our formula. Side 1 squared plus side 2 squared equals hypotenuse squared. And then what you do is you substitute in the values that you have. So if you look at your triangle, you can see that side 1 is 8. So we've got 8 squared. Side 2 is 11. So we have plus 11 squared. And the hypotenuse is x. So we have x squared. All you do next is you square those and then add them together. Now you must square them before you add them. If you do 8 plus 11 is 19. 19 squared will not give you the same value. So 8 squared is 64. 11 squared is 121. That gives me a total of 185 for x squared. If you know what x squared is, then you have to undo the square. The way you undo a square is you square root. Now please note that once I bring the square root over here, the square is now gone from the x. If you wrote a squared on your x here, you would be writing something completely incorrect. Go to your calculator. Now there is a video on calculator buttons if you're not sure how to use your square root button. Go to your calculator and find out what the square root of that is, and it is 13.6. Always remember to include your units. So x is 13.6 centimetres. Okay, pause the video and then try and do this one yourself. Okay, so hopefully you've remembered what your formula is. Side 1 squared plus side 2 squared equals the hypotenuse squared. And the hypotenuse, again, is our x, side 1 and side 2. Now the way I talked you through it before was writing out your full formula and substituting in. And that is a good way to go about these questions. But when you're more familiar with them, you might start to realise almost a bit of a shortcut. And that is basically if you just remember that when you are finding the hypotenuse, now I'm showing you an example coming up next where you're not finding the hypotenuse and therefore it will be different. But if you're finding the hypotenuse, you square the shorter sides and add them together. So what you basically have here is x squared is equal to 9 squared plus 12 squared. Now, again, remember, you are squaring them before you add them. So that's giving you x squared equals 225. Square root that. Square root of 225 is 15. So this one came out exactly, so 15 centimetres. Now, what have I done here? I've essentially just written out my formula and substituted in the values as I did before, and then I've worked through. Okay, this next example is finding a shorter side. Now we still use the same formula for this. Side 1 squared plus side 2 squared equals the hypotenuse squared. This time when you label, you'll see that you actually know what the hypotenuse is. So previously we were finding the hypotenuse, this time we are finding the shorter side. Now we've got to label then our side 1 and side 2. So let's write out our formula. So side 1 squared plus side 2 squared equals the hypotenuse squared. So what we need to do is substitute the values now into the formula. So side 1 this time is x, side 2 is 3, and the hypotenuse is 7. Now what makes this one different is that the 3 is on the same side as the x, which causes a problem. Because remember, what we're trying to get to is x equals a number. So we want all the numbers on the other side from x. That means that we're going to have to bring, now the squared doesn't make a difference. This is the same as solving a normal equation. Because the 3 squared is adding on to the x, it needs to come across and go to the other side, which means that we now have 7 squared take away 3 squared. Now please remember that you're squaring before you're adding or subtracting. So you're doing 49 take away 9, which gives you that x squared equals 40. So x obviously will be then the square root of 40, which we would just do in our calculator. So square root of 40 equals 6.3. And remember, you want to include your units with that. Now, essentially, what have I done and what's the difference from the last one? Well, with the last one, I was finding the hypotenuse. So I squared and added the shorter two sides. This time I know the hypotenuse and I'm finding x. So I square and subtract the other two sides. So basically, if you're finding the hypotenuse, you square and add. If you're finding a shorter side, you square and subtract. Now, pause the video and try this one yourself. Okay, so let's look at the shorter way, and then we'll kind of go through it from the start again. what I have said to you is, if you know the hypotenuse, so always do start by identifying your hypotenuse. Now, if you know the hypotenuse, then instead of adding, you're going to subtract. So you're basically going to get x squared equals 19 squared minus 12.5 squared. Now, they're quite awkward square numbers that we don't know off the top of our head. So what we can do is just type that into our calculator in one go. So on my calculator, I am typing 19 squared take away 12.5 squared and pressing equals. That's given me an answer of 204.75. X then is going to be the square root of that. And remember, once I've got my square root sign, I don't have my square anymore. And if I do square root of that on my calculator, I get a value of 14.3 centimetres. Now, that is a shorter way to do it, but is essentially the same as the previous way. What I would have done ordinarily is labelled side 1 and side 2. I would have written out my Pythagoras' theorem. I would have had 12.5 squared plus x squared equals 19 squared, and then I would have brought the 12.5 to the other side. But as I said, if you can remember, the shorter version of finding the hypotenuse is where you square and add, and if you know the hypotenuse, you square and subtract. That's also okay. Okay, this little section is on what's called Pythagorean triplets, and basically there are three triangles where you get whole numbers when you do Pythagoras' theorem. Now, that does not happen very often, but as I said, there are three kind of combinations of numbers where that works. The first and most common is a 3, 4, 5 triangle. Remember, the longest side is always the hypotenuse, so the 5 has to go in the hypotenuse. The second one is a 5, 12, 13. And the third one is a 7, 24, 25. Now, as well as those triangles, it also includes any triangle which is a multiple of those. So, for instance, I could also have a 6, 8, 10. So where I've multiplied 3 by 2, 4 by 2, and 5 by 2. Or I could have a 12, 16, 20, where I've multiplied 3 by 4, 4 by 4, and 5 by 4. Or I could have a 15, 36, 39, where I've multiplied 5 by 3, 12 by 3, and 13 by 3. So any multiple of those three triangles will also be a perfect right angled triangle with whole numbers on each of the sides. That means that if you are doing a non-calculator exam and Pythagoras' theorem is on it, it is going to be really one of those triangles. Now remember, it could be any multiple of them, but it will follow this basic rule of either the 3, 4, 5, 5, 12, 13, or the 7, 24, 25. Now, that doesn't mean that if you get a triangle with 3 and 4, you can just write down 5. You still need to go through and show us your method, but it does mean that you can obviously use your knowledge to make sure that your answer is correct. Okay, next thing we can be asked to do in Pythagoras is to show whether or not triangles have right angles. Now, first thing and most important thing, it is not about what the diagram looks like. That has absolutely no bearing on the answer. You might think the diagram has a perfect right angle. You might get out your protractor and check that it does have a perfect right angle. It still might not be a right angle triangle because the diagrams have not been drawn accurately. Now, the only problem then is if the diagrams aren't drawn accurately and therefore we can't actually see a right angle, well, how do we know which side is the hypotenuse? So this is where you had to have your special relationship, which is that the hypotenuse is the longest side. So if I look at my two triangles there, 26 and 12 are my hypotenuse. So how do I see if a triangle has a right angle? You check and see if Pythagoras' theorem works. Now remember, Pythagoras' theorem is s1 squared plus s2 squared equals hypotenuse squared. If 26 is the hypotenuse, 10 and 24 are your side 1 and side 2. So 10 squared plus 24 squared equals 25 squared. If Pythagoras' theorem works, this equation will work. It will be accurate. The two sides will be equal. It will balance. So let's check it. 10 squared is 100. 24 squared is 576. 25 squared is 625. So 100 plus 576 is 676. Sorry, I've just realised that I made a mistake there. I was wondering why this one wasn't working. That was a 26, not a 25. Apologies. Let me just adjust that. So that was a 26 squared. I wrote 25 squared by mistake. 26 squared then, if I can fix my next line, is 676. So what I get then is 676 equals 676. So that's right, the equation balances. So this does have a right angle. Okay, in the next example, we have then 12 is the hypotenuse. So we're basically checking if 2 squared plus 9 squared equals 12 squared. So that's 4 plus 81. 12 squared is 144. 4 plus 81 is 85. So we have 85 is equal to 144. Obviously, no, it's not. That's rubbish. That does not make sense. So if your equation doesn't make sense, if it doesn't balance, then you say it does not have a right angle. So what we've shown here is that the first triangle, it does have a right angle. The second triangle does not have a right angle. The last style of question that you can be asked in Pythagoras' theorem is your problem style questions. So let's have a look at this. A ladder of length 5 meters rests against a wall. The base of the ladder is 1.5 meters from the base of the wall. Will the ladder be able to reach a window which is 3 meters above ground level? Now, sometimes recognizing these questions can be tough, but any question really that is talking about distances where it gives you two distances and asks you for a third is really going to be Pythagoras' theorem. So we've got a Pythagoras' theorem question, which means that we need to draw a triangle. So Pythagoras' theorem works in a right-angled triangle, so draw your triangle. Now let's try and relate this to the diagram. A ladder is leaning against a wall. Now it's the ladder then that's going to be slanty. Wall obviously is vertical. So what we have here is this side here is the wall. This will be the ladder leaning against it at an angle, and this will be the ground. So the ladder is length 5 meters. The base of the ladder is 1.5 meters from the base of the wall, so that's here. Base of the ladder, base of the wall, 1.5 apart. What we want to know is whether or not the ladder can reach a window which is 3 meters above ground level. This is quite a hard question. Now what we have to do then is find out, well, what height does the ladder reach? And then we can see whether it's reached the window or not. So hypotenuse is the 5. So this is one where we know the hypotenuse and we're going to find a shorter side, which means it's a subtraction question. So 5 squared take away 1.5 squared. Now if we work that out, we get 5 squared take away 1.5 squared is 22.75. To find the height, I have to then square root that. So the square root of 22.75 is 4.8 metres. So is the ladder going to be able to reach the window? Yes. Because the window is at a height of 3 metres, the ladder goes even higher than that, so you would be able to reach the window. If, for instance, the height had come out as 2 metres, then we would be saying that no, the ladder didn't reach the window. But as long as it's 3 metres or above, then yes, you can climb the ladder and you can get to the window.